Imagine you're organizing a bookshelf, but the books are all different sizes. How do you decide where to put each book? This is a question most of us have faced at some point. Do you arrange them by size? By color? By author? It's a simple task that requires a bit of strategizing and organizing. Now let's take this scenario up a notch. Imagine you're a programmer, and instead of a bookshelf, you have a massive database. And instead of books, you're dealing with chunks of data. Just like the books, these data pieces come in all shapes and sizes. So how do you organize them? Here's where we introduce a powerful tool in the world of programming: DSA, or Data Structures and Algorithms. This isn't just a tool, it's a strategy, a methodology, a way of thinking that helps programmers sort, organize, and manipulate data efficiently. Just like you'd need a strategy to organize your books, programmers need strategies to organize data. That's where DSA comes in. DSA stands for Data Structures and Algorithms. But what does that mean? Well, let's imagine that you have a vast collection of books. You need a place to store them, right? That's where a bookshelf comes in. But not all bookshelves are made the same. Some are tall and narrow, perfect for stacking books vertically. Others are wide and low, great for displaying books side by side. These different types of bookshelves are akin to data structures in programming. In the world of programming, data structures are specific ways of storing and organizing data so that they can be accessed and worked with efficiently. Just like how the type of bookshelf you choose depends on your needs, the type of data structure you use depends on the nature of your data and what you need to do with it. For instance, if you need to store a list of items where the order matters, you might choose an array, which is like a long single shelf where you can line up your books. If you need to store a set of unique items with no particular order, you might choose a hash set, which is like having a bunch of cubbies where you can toss in your books without worrying about where they land. Now let's move on to algorithms. Let's say you've chosen your bookshelf, and now you need to figure out how to organize your books. Maybe you want to sort them alphabetically, or by genre, or by size. Each of these strategies is a different algorithm. In programming, an algorithm is a set of steps or a strategy to accomplish a specific task. Just like how you choose your book organization strategy based on what you want to achieve, you choose your algorithm based on the problem you're trying to solve. So, in a nutshell, DSA provides us with the building blocks, data structures, and strategies, algorithms, to effectively manage and manipulate data. Whether you're organizing books or writing a complex software program, understanding DSA is key to creating efficient and effective solutions. So how does DSA fit into TypeScript, a popular programming language, you might ask? Well, let's dive right in. TypeScript, a strong ally of JavaScript, brings in the power of static typing and makes it a favorite among developers. The static typing feature of TypeScript provides a way to check the type of a value at compile time, making it a safer bet for implementing data structures and algorithms. Now, you might be wondering, how does TypeScript's static typing help with DSA? It's quite simple. With static typing, you can define what type of data a variable can hold, reducing the chances of unexpected errors. It's like having a personal assistant who checks your work for mistakes before you present it. This makes it easier and safer to implement data structures and algorithms, as the type of data you're working with is always known. Let's take a simple example. Consider an array in TypeScript. In JavaScript, an array can hold different types of data at the same time, but TypeScript allows us to define an array that holds only a specific type of data. For instance, we can create an array that only holds numbers. This comes in handy when you're dealing with data structures, as you're assured that all elements in the array are of the same type. Similarly, we can define objects in TypeScript with a specific structure. An object can be defined to have properties of certain types, and TypeScript ensures that the object always adheres to this structure. This gives us a clear picture of what the object looks like, making it easier to work with. So when you're implementing data structures and algorithms, TypeScript is like a trusty toolbox. It provides you with tools like static typing that help you to create robust and error-free code. And the best part? It's all done in a way that's easy to understand. No need to worry about unexpected surprises in your data or your code. With TypeScript's features, we can implement DSA in a way that's easy to understand and safe to use. So why not give it a shot? There's a whole world of efficient and effective coding waiting for you with DSA in TypeScript. Like any skill, mastering DSA takes practice. It's not just about understanding the theory, it's about rolling up your sleeves and diving into the code. You need to get your hands dirty with TypeScript and DSA, build your own data structures, and see how they interact with different algorithms. Consider using online coding platforms. They're treasure troves of coding exercises and programming challenges, perfect for honing your DSA skills. Also, don't shy away from textbooks. They might seem old-fashioned in this digital age, but they're packed with insights and exercises that can help you understand the nuances of DSA. Try to implement different data structures and algorithms every day. Experiment, make mistakes, learn from them, and then do it all over again. This hands-on approach will help you grasp DSA concepts at a much deeper level. Remember, the key to mastering DSA is practice, practice, practice. So start coding.